Hey guys, it's Miss Delcambre. So today is Tuesday, the 19th of January, and here's a rundown of our day. So you'll need glue, scissors, your journal, pencil, a highlighter, and your notes on 11.1. I forgot to type that down. Make sure you have your notes on 11.1. All right, so we're going to look at our week review, what we're doing this week, and then we're going into our notes, and I'll kind of touch on our homework for a little bit. So let's get started. Okay, so here's our week in review. So yesterday was a holiday. Today we're going to talk about modeling equivalent expressions. Tomorrow we're doing I think, one of the easiest parts of sixth grade math, or at least the top 5 easiest. Evaluating expressions. Then we have generate equivalent expressions. And then Friday we have IXL. If you're with me, we have Builder 16 this week. If you're with Miss Peeler, I believe she has Builder 17. They're a week ahead of us. All right, so that gives you a kind of a rundown or a scope of what we're going to be doing this week. So let's get going. So I want you to cut your notes. There's a little section here, and I want you to cut that, and you're going to glue that on the next side. So let me lock in my camera because it keeps zooming out. So today is 1/19/2021. And we're going to be talking about writing algebraic expressions. So right now what we're talking about is the basics of introduction of algebra. Okay? And then you're going to start with algebra like right now in 6th grade. Then you're going to move on to 7th grade and you're going to build on it with 8th grade. When you get to high school, you're going to take algebra 1, algebra 2. You're going to build on it there. So this is basically our first foundation of algebra. So we want to make sure we understand it, know it, have a great concept of it. So we're going to talk about writing algebraic expressions. Now, an expression is just kind of like a math sentence, all right? It's just a math sentence. And when we write an equivalent expression, so equivalent expression, I don't know if I'm using the right word, but equivalent, like the prefix, I guess is what you can call it, right here, means equal, like equivalent, equator, splits world into 2 equal halves, equilateral triangle. Okay, equivalent means equal. So when we're talking about expressions, equivalent expressions, these are expressions that have the same value. Expressions with the same value. Okay. So equivalent expressions are expressions with the same value. Key little note there. So when we talk about algebraic expressions contain one or more variables. And you're like, well, what's a variable? Well, let's just look and see what the definition is. So a variable is a letter or symbol used to represent an unknown or an unspecified number. So it's just those letters like X. When you've been seeing X, that's a variable. It means, hey, I'm going to put this letter there. I don't know what it means yet, but I'm going to find it out. So it's a letter or symbol to represent an unknown or an unspecified number. The variable may change. Say in one question, X, you got X is 5. Well, in the next question, X could equal 12. X can change from question to question. However, X cannot be 2 separate numbers in one question. Okay? Now, an algebraic expression is an expression that contains one or more variables. Variables is a letter or symbol to represent an unknown, and may also contain operation symbols such as add, subtract, multiply, and divide. I put a division symbol, divide, or multiply. Okay, switched them around when I was writing them. So all 4 operations are what you're going to be seeing. Okay, now we have the word constant. And a constant is a specific number whose value does not change. It stays the same. It's a constant. So when we have algebraic expressions, 150 plus y, well, that 150 is the constant, and that y is your variable. Okay, w plus n, x. Now, do you see with all your algebraic expressions, they all have variables. All have variables. Okay? But with our non-algebraic expressions, you see 15, 12 minus 7, 9 over 16, these have no variables. There are no variables here. So there's no variables in non-algebraic expressions. Algebraic expressions all have a variable. So just remember, algebraic expressions have some letters in there that represent unknowns. Now, when we talk about our algebraic expressions, adding and subtracting, same way that we've been doing it, you see the same symbols. However, with multiplying and dividing, there is a difference. So when we multiply, we don't use the X anymore. What you will be seeing most often is a letter next to the number, okay, that's being multiplied by. So highlight it, star it, memorize it. Remember that that means multiplication. All right, that will mean multiplication. It will always be your number and your variable, followed by your variable, and this represents multiplication. Okay, all the time. You're going to see this probably 90% of the time. Okay, so get in the habit of seeing it. Now with division, they don't use a little division symbol like that anymore. They use it in fraction form. So like 3 over n. So you're going to see it in fraction form. Fraction form represents division. Okay, so you're going to see it mostly like this now. So I want you to make sure that you're understanding that we're graduating. We're not seeing this anymore when we're working with our algebraic equations. You're going to see it like this, and that represents division. Okay, now when we're writing our expressions and our equations, it may be written up as words, and when we write our expression, we want to write those words in math form. Like, how would I write that? So we have our 4 operations here. We have addition, subtraction, multiplication, and division. And here are some key words to represent addition, such as added to. Okay, plus. Hey, that was kind of like the first word when you started out with adding is the word plus. 4 plus 4. The sum of 3 and 2 is 5. More than. Addition. So those words are associated with addition. So the words associated with subtraction is subtracted from, minus, difference, less than, take away, and taken from. Okay, so these words are associated with subtraction. All right, the words associated with multiplication is times, multiplied by, product, and groups of. Okay, again, these words are associated with multiplication. Finally, we have division, which is divided by, divided into, and quotient. Again, these words are associated with division. Now, these aren't the only words, okay? These aren't the only words that can represent multiplication. These aren't the only words that represent division. But most of the time, when you see these are the ones that you will mostly see, and they represent the following operations, okay? So let's turn our page over. So we have n times 7. So how would I write that? So I have it in words. I need to write it with numbers so that someone can read it. So n times 7. Even though n comes first, I'm going to write 7 first. So it will be 7n to show that, because my number always comes before my variable. Right, number 3, 4 minus y. So again, just like I start off 4 and I'm subtracting y, minus y. 13 added to x. Okay, now this one, even though this one, the question in front of it, 4 came first and I wrote 4, here 13 added to x. So I'm going to start with x and I'm adding 13 to it. Okay. All right, my next one is number 5. And this is a division problem because I know it's fractions. So my division problems are divided by, divided into, and quotient. So divided by, so I can say x divided by, I'm trying to make that a v, divided by 12. Okay? Or 12 divided into x. We can also say the quotient of x and 12. Okay? So those are 3 different ways that we could show this. All right, number 6, 10y. Okay, so that means when it was together, I know it's multiplication. There's 4, so times multiplied by product or group sum. So again, I'm going to come over here. I could say 10 times y. Okay, so there was times multiplied by, so we could say 10 multiplied by y. See, product, the product of of 10 and y. And finally, we can say 10 groups of y. 10 groups of y. So those are 4 different ways we can show this. Okay, real quick talking about multiplying, dividing, adding, and subtracting. Okay, when we're dealing with adding, subtracting, multiplying, and dividing, multiplying and adding, it really doesn't matter which way I have my numbers. Okay, we're going to talk more about this on Thursday with our different properties. But we can switch up the numbers with addition, and then my answer still stays the same. And I could switch up my numbers with multiplication, and my answer still stays the same. However, that rule does not work with subtraction, and division. I'm going to show you. So, say, I'm just going to do some easy numbers, some simple numbers so that you can see. I'm going to change my colors out. All right, so I have 2 and 3. So my number's 2 and 3. So I have 2 plus 3 gives me 5, which is the same as saying 3 plus 2 gives me 5. Okay. Then I'm going to, okay, so addition, no matter which way, if you're doing 2, which way you arrange your numbers, they're still going to give you your answer of 5. So I'm going to keep the same numbers, but now I'm going to multiply. So 2 times 3 gives me 6, and 3 times 2 gives me 6. So do you see how no matter which way I arrange my numbers, I'm still getting 6? Okay, now that is with adding and multiplying. Now, when I come to division and subtraction, it's a whole different ball game. It depends on what number comes first. Because 2 minus 3 gives me a negative 1. And then if I take 3 minus 2, I get a positive 1. Different answers, totally different meanings. One's a negative 1, one's a positive 1. Same with division. So 2 divided by 3 gives me 2/3, which is 6/600. 2/3, which is a repeating decimal. Okay. Now if I flip it around and 3 divided by 2, that gives me 1/2. These two answers have different value. So it's very important when you have a subtraction or division problem that you're trying to figure out what comes first to read carefully. Okay, read carefully and see which number is going to be your first number, which number is going to be your second number. Okay. So that does it for your notes. Let's go real quick and look at your homework, which is 11.1. modeling equivalent expressions, and I'm going to minimize this page. Come over here and pull it up, if it pulls up in time. All right, let me find my Google Classroom. Let's scroll down to Google Classroom. Okay, so pulled it up, oops, and now I have it over here. All right, so what we're going to do is we're going to look at the first question, which I've kind of went ahead and forgot to erase all my little clue hints. So Jessica rode 9 miles farther than Roger rode. Let R represent the number of miles Roger rode. Write an expression for the number of miles Jessica rode. So we see farther, 9 miles farther. I have it highlighted up there. Farther means that that she's adding, so she's increased. She's 9 more miles than whatever Roger rode. Well, I don't know what Roger rode, so I'm using the variable R. Therefore, my answer could vary. There we go. So R plus, okay, Kimmy, work with me here. Seriously, what's going on with you right now? R plus R plus, there we go. 9 equals, oh, what the heck? What happened here? I didn't know that. That was interesting. I didn't need to put an equal sign there, but when I did, it made a kind of like a spotlight. All right, so R plus 9 is my expression there. Okay, let M represent the number of children playing soccer. Those children are separated into 4 equal teams. Write an expression for the number of children on each team. So we're separating, and separating means division. Okay, so I'm going to put my little symbol right there. Help me remember. So there's my symbol. Come over here. I'm going to just move my symbol down. Symbol will move down for me. There we go. So now I'm going to be dividing. All right. Because it says separated. That was that key word. Remember, not all those words on that sheet meant add, subtract, multiply, and divide. But separated into 4 equal teams, we know that that's division. So we're going to take our M, I'll come over here, we'll take our M and we're going to divide it by 4, and we could show it like this. M divided by 4. There we go. Okay. Now here's our next question. Glenda bought some apps for a tablet. Each app costs $5. Let N represent the number of apps she bought. Okay, each app, keyword there, means that I'm going to be multiplying. And you can think about this in your head. Well, if you bought 1 app, it costs $5. If you bought 2 apps, it would cost $10. 3 apps would cost $15. So we're doing this by multiplying. So I'm going to take $5 and multiply it by N, or 5N. Same thing, I just put a dollar sign, knowing that my answer would be with money. Okay, so numbers 4 through 14, I'm just kind of, I think that we did 3 together as a class. So 25 multiplied by 3, you're just taking this in words and making it a math sentence. So that would look like 25 times 3. Okay? The difference between 48 and 13. Difference, we know subtraction. So I'm going to have 48 minus 13. Number 10, 189 subtracted from t. Subtracted from, so meaning I start off with t and I'm subtracting 189. I'm not looking for an answer, I'm just looking for the expression. Now, 12 and 13, you're going to write with words, just like up here, what this would be and what this would be. And number 14, you're going to write an expression that has two terms. Your expression should have a variable and a constant. Variable and a constant. So that does it for me today. So your homework is 11.1. If you have any questions, please make sure you email me or let me know in class. And have a good day. We'll talk to you later. Bye.